Good morning, everybody. Welcome to the Data Center of 2025 webinar. My name is Jawahar Swaminathan from Raritan, and will be your moderator today. We also have Jim Treadway, Chief Engineer at Modular Corporation, Ken Copeland, Vice President at Opticool Technologies, and Jeff Fedacaro, Senior Analyst with 451 Research, joining us for the roundtable later as well. We'll start off with a polling question, followed by Jeff presenting the findings of 451 Research commissioned by Raritan on data centers of the future. We'll then finish with a roundtable discussion on the same topic. Now to the polling question. We would like to know what types of data centers you use today. On-prem, colo, cloud, or a mix of all of the above. We'll give you a minute to respond. The responses are coming in. So at this point, I'm going to turn it over to Jeff to see what he thinks about the results. Any surprises, Jeff?
Yeah, thanks, Jawahar. So it's looking like zero cloud, which is very interesting. I was expecting more of the hybrid type response because, the world's becoming more, hybrid IT is becoming more the new normal. And, from our studies, we've seen 33% of workloads today are based on or are residing in cloud-based architecture. So that's kind of interesting. So we've got an audience that's got a lot of on-prem and a lot of, 65% saying mixed. So I'm going to jump into when we envision, sort of these data centers of the future, we think about meeting the demand for this ever-increasing digital services. And the data center infrastructure itself needs to embrace new technologies and new innovation, but it's also got to mitigate the future disruption, right, as best as it can, given our outlook today. So we're going to spend the next 15 minutes just taking a look at a reality check of the state of the data center market today, and I'll cover a few key technology trends, and then look at some of the future data center requirements and a schema that covers, future data center functions. So the world is moving toward this hybrid IT environment, and enterprises are adding more co-location and public cloud capacity off premises. So the cloud remains a significant competitive threat. Our voice of the enterprise data here, and this is a 451 product that surveys over 85,000 members of the 451 Alliance, and this is on a quarterly basis. And this shows a time series of workloads, and you can see a dramatic shift to these cloud-based architectures. And this includes on-premises private cloud, and that represents about 45% of workloads today, and then expected to grow to about 60% of workloads by 2019. So one of the key drivers for moving to the cloud is going to be price, right? It's probably the first thing that came to your mind, and you can see that the cloud infrastructure continues to decline rapidly for this pricing. We've got a 451 cloud economist, and he tracks this very closely, and I think the key here on this slide is that his team's forecasting an acceleration in that pricing decline even over the next 12 months. So while price is not the only factor influencing the best execution venue, there's also availability and resiliency, there's security requirements, and price remains the important factor. And the reality is the competitive pressure from public cloud is only going to intensify. So the requirements for enterprise and co-location data center operators to be more cost effective, to be more agile, this has really never been greater. Now, despite this shift to the cloud, overall there's still a lot of enterprise and colo data capacity out there. So this chart's a different view. This is showing global data center square footage by owner type. And you can see enterprise today is about 78%, and the multi-tenant data center, so that includes retail and wholesale, is representing about 15% of square footage. So most new build data centers, they're going to be operating at more optimal availability and more optimal energy efficiency, probably closer to their theoretical design targets. So it might be argued, that the two biggest challenges of data center technology in the past 30 years is being addressed. But despite this progress, the pace of change in the data center industry is expected to continue, and it's likely to accelerate over the next decade and beyond. So below are some of the underlying forces that we identified in the white paper with Raritan that's driving that change. So demand, this is talking about data center capacity. It's struggling to keep up with the explosive demand for IT and digital services. Most enterprise data centers run at very low utilization and are over-provisioned for power and cooling. So there is opportunity to improve utilization. There's going to be some migration of workloads off premises, but there'll be opportunities to optimize efficiencies in these existing sites. The next driver is cost transparency. So some data center cost items include, let's say, power usage, IT capacity, showback or metered chargeback, and real-time costing. So leading this initiative has been co-location and service providers, and that's been prompted by demand for better transparency from their customers. And in our survey, the work shows that customers want even more visibility and transparency and across their entire on-prem and off-prem infrastructure. Convergence. So to be clear, when we discuss in the Pathfinder, it's not about converged IT. Rather, this is talking about the merging of IT and facility organizations. That's IT with OT. So we're seeing the integration of these two functions and the responsibilities has shown to improve IT workflow and facility management. And this is going to become more critical as workloads move off premises and it gets more complicated, particularly in the cloud. So data center operators still need to maintain application availability and service level agreements in these off-premises targets. And having the IT and facility responsibilities on the same team has proven in most cases to enhance the management of these processes. Next is an industrialization and standardization. So we anticipate increased adoption of prefabricated modular data centers. So as data centers become more industrialized, meaning more IT components will become commoditized and integrated, they will be assembled, pre-tested in a factory-like environment. Customers can still retain some choice over specific requirements and design, but the build-out will become much more modular, and I'll discuss this in more detail later. And then finally, R&D. So this is ongoing, and in the white paper we discussed some of the emerging technologies in more detail, but this can be potentially disruptive longer-term technologies as quantum computing or silicon photonics. We talk a little about high-speed, high-bandwidth networks, including 5G. So just moving on to technology trends, in 2017 and beyond, we were looking at data center management software. So this is becoming more important as data centers become more data-driven. And there's also cloud-based services that are emerging today, what we call data center management as a service. So the role of software in data centers is going to accelerate. Data center management as a service we expect to become even more important. And then you've got artificial intelligence, machine learning, analytics, big data, IoT-like services. This is all going to add to the value of DCIM. The next trend is energy and power. So we're becoming more distributed and transactive from multiple energy sources. So you've got the bigger data centers operators today are commonly owning their own power sources. Factors include security, availability, and efficiency. This is all going to drive dynamic energy investment. And then finally, software-defined power. And today I'd say that that's more aspirational, but software-defined power is using software to continuously match your power resources with your data center capacity needs. So part of the power trend is this increase in rack densities, and we've seen this trend creeping up. But the majority of data center racks today, based on the survey from the Uptime Institute, are still below 6 kW. But again, we think with the workloads today and the more efficiencies, we're going to continue to see this creep up and get even higher. And part of this, increasing rack power densities, is going to have a direct impact on your data center cooling technologies. So we've seen this driving demand for more advanced cooling techniques, and the survey shows that more data center operators at some level are beginning to adopt more advanced cooling technologies. That could be, hot or cold aisle containment, in-rack or in-row cooling, as well as starting to see direct and indirect, fresh air economization. Another trend we touched upon in the report is the open compute architectures or open architectures. So Open Compute project that was started by Facebook back in 2011, and it's probably the largest community out there. It's had limited adoption outside the big hyperscalers, and we estimate it represents about 2 to 3% of global data center spend today, but it's having an impact on designs. And the easiest way to illustrate this is to show today's current architecture. So here's a traditional data center design. On the top, you've got your electrical distribution, you've got generators going to UPS with conditioned power that goes to your racks and IT load. On the bottom, you've got a fairly traditional chiller plant. You've got your cooling towers, your chillers, your pumps, your crack units. When you look at the open architecture, this is what they want it to look like. So you've got the generator still, but you've moved your battery backups, mostly lithium ion, into the rack. So it's matched with your IT load. And on the cooling side, you're going to air side economization and air handler units. So simplifying it, and it's creating some changes within these data center architectures. And the data center standardization industrialization. So this is the shift to prefabricated modular data centers I talked about before. So you got data centers that are going to become more highly industrialized. So they be thought of as more like products than buildings. And this category includes specific prefab modulars, but it also includes components such as electrical skids or, say, prepackaged chiller plants, for example. We at 451, we size this market, so we showed a total prefabricated market to reach over $4 billion in revenue by 2019. And we really break this down to 3 categories. So we've got the containerized and custom enclosures in one bucket. And we think about scalable building structures, and that includes those electrical, mechanical, modular systems I was talking about. And then finally, in a much smaller bucket, is going to be your micro-modular data centers. So this could be a rack or a half rack, and the IT is tightly integrated with the enclosure. And it's got its own power, it's got its own cooling inside, it's got maybe a backup battery system inside, and that's your micro-modular components. So suppliers are starting to think about industrializing this process. And then standardization can significantly shorten that time to market. So one way we think about this is it's not unsimilar to how aircrafts are assembled today. And then just an example. So this is when we think about prefabricated modular data centers, it may not be what you think. So I like this photo because it shows a prefabricated white space. And from the inside, this looks like more of a traditional stick build. But there's going to be, still many preconceived notions about what prefabricated data centers are, but they're going to range anywhere from multi-story buildings to these very small micro-modular single rack enclosures. And I think the perception here on micro-modular is changing. So now we're going to talk about some of the future requirements and the outlook. So future-proofing strategies. We talk about this in more detail in the report, but the areas we focused on was one, management software. This is about enabling more infrastructure visibility and more controls. The next is reliable power distribution and storage. So how do I diversify my power sources and being more efficient? There's open source architectures. Here, it's the potential for significant CapEx savings up front, as well as operational savings, and then it offers increased interoperability and serviceability. And then finally, consider modular designs. This is about decreasing your time to market and adding incremental capacity on a more on-demand basis. So in the Pathfinder report, we discuss and define different data center types. But shown here, we've established data center type schema under present. And we've been in the process of actually formally updating this schema, but we're beginning to see clear data center types, and that's emerging based on design. But more recently, it's also clear that the lines are getting somewhat blurred. And now we're starting to see more of what we'll call a function or business role aspect to this as well. So to clarify what I might mean by function or business role. So one example might be on the right-hand side, if you look under future, would be service provider or clouds. That may require a very specific physical data center type to serve that function, or even multiple types here. But that service provider might not own their own data centers. So it's going to create a functional role. Another good example might be high performance compute. That requires a very specific data center design, so that's high density, low redundancy. But hyperscalers are offering this service, right? So some of that high performance compute function may migrate some capacity into the hyperscale service, but that high performance compute and specialized data center bucket will still have very specific physical data centers. And then one last, so when we talk about edge data center layers, I just wanted to show this real quickly. I'm not going to go through this in detail, but here we lay out what the different types of data centers serving sort of that specific edge compute or IoT workloads and what it may look like. What the key to determining factors are around what we describe as latency, criticality, which is, in other words, how important is availability. And then the third vector is around data volume. So some of these sites may have extremely high data volumes, may have some extremely low data volumes. So based on those factors, we've got the edge, near edge, and core laid out here. And so to give you an idea, in the low and ultra low latency, we're talking about under 10 milliseconds. So that's going to be your 5G cell processing. That's going to be IoT gateways. And then when you move at the very high end up to about 2 seconds, so 2 seconds or greater latency, these workloads could also be deemed IoT applications, but they don't need to be executed at the edge. So that can move all the way up into a core data center because the 2 seconds or higher latency may be acceptable up there. So I think you're going to have a mesh of data centers and interconnections between these different layers. So finally, just to wrap up, when we look at the outlook, data centers are going to look increasingly different according to the function. They will mostly be evolutions from today with some new form factors. And then finally, areas that we focused on were energy efficiency and data center management software. So I'm going to turn it back to Jawahar.
Thanks, Jeff. Lots of good insights there. The entire research paper is available for download, as well as the slides that we looked at. Now I'd like to invite our experts to join our roundtable discussion. Again, we have Jim. Jim is no stranger to developing and applying progressive and sometimes even disruptive technologies and methodologies at MITRE. We have Ken, that works with customers to provide innovative and future-proof cooling designs. Jeff, you heard Jeff so far, not only knows data centers, but also coding. So we have a panel of experts with very varied experiences to learn from. So I'd like to open by asking our experts an important question. How do they see themselves getting to their data centers in 2025? Are they going to be arriving in a self-driving car, air taxi, or teleport? Jim?
I'm teleporting, absolutely.
Ken?
I believe I'll be getting work done while my car drives me there.
How about you, Jeff?
I think maybe Amazon's going to deliver me by drone.
There you go. None of the above, huh? Very cool. So Jim, if I can ask you an utopian question, do you see a future where the enterprise data center completely is gone? It doesn't exist in the long term, or are we still going to see them around in some form or the other? I'll start with Jeff.
I think over the next, decade or two even, hybrid is becoming the new normal, but I think enterprise data centers are going to continue to exist. Some reasons are going to include, legacy applications that might not port well to the cloud environments, or legacy applications that have high interdependency on other applications. And then there's certain sectors, so industry regulations. You've got data security and data sovereignty to worry about. And then just finally, I would touch on, on-prem private clouds that data showing, we've got data showing that for certain workloads that actually makes more economic sense than using the public cloud. So I think they'll still be around.
Yeah, I think Jeff touched on a couple of key points. I also don't think data centers are going away anytime soon. I think there are many types of workloads still that just aren't really economical to run solely in the cloud. We found that for sustained analytics type workloads, as example, the cost of cloud just aren't really that compelling. And hybrid cloud is one way of getting that cost down for more intermittent type workloads where you can kind of find economies of scale when you need it, but then being able to pull them back down when you don't. I think another big driver really is security, and a lot of the compliance regs can also be drivers to keep your services on-prem. I think in general, a lot of the cloud providers have been slow to respond to a lot of the changes in federal and DoD compliance for the government clouds, which are also more expensive than the commercial clouds to begin with. So it's always going to come down, I think, to making the best business choices for how you're going to deliver services to your customers most efficiently. So I do see data centers evolving in the future and becoming much more efficient and flexible, but I still think they're going to be around for a long time.
So a follow-up question to that, Jim, would be, what options do you consider today when you plan a new build, for instance? I'm not talking about building a data center under the ocean or something, although it has been thought about. In other words, how much do you consider cloud as an option, and how are vendors adapting to such a change as well?
Well, I think a lot of it, at the end of the day, it's an economics decision. It's a changing landscape, and so for us, it's really trying to find better ways of how do I predict costs of running different types of workloads. Where can I get the most bang for the buck? And if you look at that holistically, it's going to be a different calculus for every organization depending on what they're doing, what the environment is that they're living in. We have stuff on-prem, we have stuff up in the cloud, but it's really been a conversation about where can we best deliver value to our customers at a price point that's most effective.
Got it. How about you, Ken?
From a supplier standpoint, I would say a large percentage of the customers that we engage are considering some sort of hybrid environment. If the customer is moving into a colo facility and wants to utilize our cooling technology, it really changes the dynamics of our engagement with that customer as well as the facility that they've chosen. It definitely requires a working relationship with the facility managers of the colo as well as the end user and customer. In this regard, the colo really becomes the customer as well, so you have to work with both entities.
Got it. And Jeff's presentation touched on software that's becoming very important in managing data center power and cooling. I mean, I can't even turn my lights on without relying on software. That's how reliant we are on software. So what are the trends that you see in this regard? I'll start with Ken and maybe ask Jim as well.
Yeah, software is a very powerful tool, and it helps the customers generate data they can use to optimize their operations. Jim Treadway on the call today, he's a true expert when it comes to utilizing software in the data center to perform different functions. So what I'll focus on, strictly the cooling aspect. In my opinion, software helps us get to a more granular level and see what's really happening inside the data center as well as the racks. For our product, it's the ever-changing heat load of the customer that we want to monitor. That's all the way down to the specific RU space in the rack where most of the heat is generated. We place sensors in our rear door heat exchangers that monitor the changes in that heat load, which in turn, tells our system to slow down or speed up accordingly, and this really helps drive efficiencies. It allows us to control the amount of energy that we use to extract a specific amount of heat. So say in the middle third of the rack, that's where you're getting the most heat and creating your issues. And we need our fans in our active system, that's the key word is active, to run at a higher RPM, in that specific location. But then also we need it to slow down once the heat load is reduced. So that variable speed, the software helps determine that speed, and it's helping drive energy consumption, reduce energy consumption, when loads are minimal. For us, for OptiCool, it's about driving efficiencies. I know Jim's got a lot he can share, in regards to utilization of software. Jim?
Sure. I think for us, it's really been about trying to make the data center, a more intelligent resource. Has lots more data to drive the different business and technical decisions. So we've been putting, to kind of use the software kind of model, you got to have the data behind it. So we've really been putting a lot of effort into really expanding out the layers of instrumentation that we've put in place, not just power and cooling, but really kind of looking at it as an IT challenge as well, looking at system resource utilizations and workload optimizations. It's so cheap to get that data now, using intelligent PDUs and wireless sensor tagging and tying in tools like Metasys and SCOM and things like that. All that data is there, but how do you start making better decisions about how to maximize the effectiveness and minimize costs? So we've seen a lot of value over the past couple of years in, not just collecting the data, but starting to start using analytics tools to start creating kind of unified operations, customer dashboards. So the ops teams, the facilities teams, as well as the end users are all really coming from the same playbook. So we've put a lot of work into using kind of analytic tools like Tableau and Splunk and start bringing together a lot of correlated data, not just from the data center, but also from the building control systems and from all the IT systems, so that we're providing not just reports of what has already happened, which is kind of what DSIM has done traditionally, but really going beyond that and to start being able to perform predictive analytics on the data center and the services it delivers. And this has allowed us to make a lot better decisions on how to maximize every aspect of our data center. I would probably add that I think a key piece of being able to do this is not just collecting the data, but really on starting to develop more robust analytic skill sets internally so that you can start learning to use different types of tools to start giving you the insight you need to maximize the effectiveness of the data center, make better investment decisions, whether it's on-prem or not. Internally, we call this not doing big data, but we kind of think this as medium data analytics, essentially trying to take a page out of the data science playbook and apply it to the data center. And that's something we've really gotten a lot of value out of.
Well, you heard it here first, folks. Medium data. That's a new term, just like big data. So, Jim, I can see how you're going to get a lot of questions on the best practices that you've done so far. So
sure.
Be prepared. Jeff talked about energy sources in this presentation. So one of the things that I want to know is, how are data centers changing their relationship with their utilities? Do you see a future where we don't need utilities? Ken?
Yeah, it's an excellent topic, Jawahar. It's imperative that the data center folks have a working relationship with the utility provider. Even more so in the future. In every U.S. market today, utility offers some sort of incentive program to encourage, the deployment of energy efficient equipment. By having a working relationship with these energy providers, the customer stays abreast of what's available to them at any given time. They can reap the benefits of, being able to secure an energy rebate. One of the benefits that we provide to our customers is an introduction to the utility if they don't already have one. We help them navigate the programs to see what's available in regards to energy rebates for upgrading their cooling. In most cases, the customer is able to recoup a substantial amount of their CapEx cost, associated with new energy efficient systems. We recently, as an example, had a customer in San Antonio, Texas, that recouped 35% of his total CapEx cost of our system, by showing the utility how much energy they're saving, and by 2025, I don't see the cost of energy going down. So I think it'll be even more important, moving forward for customers to take advantage of what the utility offers them. Jim?
Yeah, I think clearly the cost of energy is a major factor in all of this, and I think everybody's looking for ways to reduce costs. There's lots of existing and some emergent technologies that potentially can reduce energy costs. Some are probably more ready for prime time than others. And I think also, and Ken touched on this, I think the region of the country you are in can also be a big factor in the range of options that are going to be available to you. So for us, like our main campus up here in Massachusetts, we have very reliable power, but it's 14 cents a kilowatt. It's a little more expensive than most. But we also have access to very clean and very inexpensive natural gas. So we've actually been looking into deploying a solid oxide fuel cell capability on-prem to potentially flip our power model upside down. So basically use a fuel cell as our primary power source for the data center, but use the street grid as our backup. So for us, the big advantage is this could eliminate the need for expensive generators and underground diesel storage tanks, and just that's actually a big challenge for us since our campus is in a protected wetland zone. That creates some challenges. It also would open up the possibility for us to be, potentially generating excess energy and selling it back to the grid to try to, capture, some cost savings there. We've already seen actually 3 companies that we've gone and taken a first-hand look at down in Connecticut that have actually already deployed these. And so we actually have a project underway right now working with our facilities team to dig more deeply into this, and we're thinking, a possible deployment maybe a couple of years out. We're still kind of looking at that. But I think there's a lot of things that people could be trying to explore to, try to basically become self-generating if possible.
We're getting a lot of questions from the audience as we speak. I'll try to bring as many of them in as possible. Here's one. Will edge computing infrastructure play a larger role in the future of data centers? I mean, personally, I would say I prepare to rent out my garage as an edge data center one day. Jim?
Yeah, I mean, there's lots of definitions of edge computing. I think our view is we really see it as a logical evolution of the cloud. I guess a realization really that one size is not going to fit everybody. Fundamentally, it's a way of distributing your compute services closer to users so they can do their work without the wasted overhead of moving terabytes or petabytes of data over a long haul. We've got a little over 40 locations around the U.S. and about a dozen overseas, and more than a few of them are already doing some pretty heavy work that has some large data sets. So we've been looking at some of these locations as good opportunities to start using some edge-type concepts and start delivering bursting compute resources to them without having to drag large payloads across our WAN, which really is an impediment to them running services at the pace they need to run at and doing that cost effectively. So I think, again, everybody's results will vary a little bit, but I think that kind of model definitely has some value. I think there's probably, I guess the flip side of that is that I think it does take, you've got to have some decent capabilities are in existence to kind of really take that step into kind of the next layer for edge. I don't see a lot of people jumping directly from a on-prem model and saying, hey, let's just go edge now. I think it's really going to be kind of an extension of this hybrid model and being able to kind of bring those out and extend those resources out on demand.
And Jeff, do you have anything to add?
Yeah, I mean, just from based on that one chart I put up on the edge, near edge, and core, we're a new major category as far as physical structures that are coming up is the micro data center, and that's been fairly disruptive because it could be new form factors, and they could be very, these can be placed in sort of rural areas that you need very ruggedized, micro modular enclosures. That's also going to require much more automated monitoring and remote monitoring and much more automation and controls in those data centers, and they're most likely going to be designed to be unmanned, right? So that's been changing sort of the form factor, and it's still evolving now. And it's going to be, so more software-based distributed resiliency is going to be one of the requirements. So yeah, I do think it's going to be fairly disruptive.
And along that line, what do we do to future-proof existing data centers? I mean, to make them more agile for the future. Ken and Jim, can you share some of the things that you've done in your experience?
Yeah, absolutely. OptiCool, we believe in cooling on demand, not cooling the entire room. that's an essential part of an efficient data center, not just now, but also into the future. I like to provide a simple example, that's easily understood. What the data center industry has done for the last several decades, really always, is to keep our can of soda. We keep it cold by putting it on the kitchen counter, and then we turn the house air conditioner down to 37 degrees to keep your Coke cold. Why not put the soda in the refrigerator and make the kitchen a comfortable 72 degrees? The point being is we're cooling the entire facility when really what we need to be focusing on is the equipment and the racks. And hopefully by 2025 we'll be past the days of blowing massive amounts of cold air into the facility and move to a more, on-demand model that doesn't have to be completely built out day one. It's available to you when you need it, but it also, helps out on CapEx aspect as well. You simply build out your room for us with manifolds, that deliver cooling medium. For us, that's refrigerant. And then plug the racks in as you build out the space. You've got the cooling on demand. So you take out the day one guesswork and really, you build a model that can accommodate an 18 kilowatt rack next to a 3 kilowatt rack and have no issues. Because on day one, you really have no idea of what lies ahead. So it's that uncertainty, of being able to provide cooling on demand and be agile, and save massive amounts of energy, where you can. I think that's part of future-proofing.
Yeah, I think
Jim?
I think Ken nailed a couple of key points. I think when we did a project starting back like 3.5 years ago, we commissioned a new data center in 2015. I think right before that happened, I think one of the key questions that came forward is kind of the way a lot of projects start is they ask, how many kilowatts or megawatts do you think you're going to need in 5 to 10 years? I think that's the wrong question. I think the best way to future-proof yourself is to not try and predict the future. If you do try to do that, I think you're going to typically get it wrong. Our view is you don't want to make investments based on projected demands or guesstimates. It's a bad investment strategy. So I think we've tried to future-proof ourselves by developing a strategy that allows you to rapidly respond to unanticipated demands, but doing that at an incrementally scalable, very predictable cost point, both for CapEx and OpEx. So essentially, our plan supports, essentially modular multi-densities from roughly 5 to 30 kilowatts per cabinet. I mean, in the past couple of years, we've gone from an average cabinet density of, about 2.93 kilowatts. Now we're up to, I think our average right now is a little over 12, and our peaks are up into the, 19s and 20s. But we were able to do that very cost effectively by basically staying with a very modular system, relying on refrigerant rear doors, switching to a more flexible and less expensive 415-volt power distribution model, going with larger, more intelligent PDUs with higher power capacities, more outlets, even taking it beyond the traditional data center stuff. We started then embracing like spine leaf network architectures with, automated policy controllers, recognizes that in the future our transmit speeds are going to go much higher. We're already at 40 gig. We're anticipating 100 gig or 400 gig in the future, thinking way out there. So we basically adopted a base 8 fiber architecture instead of the traditional base 12. So I think the whole theme is really trying to minimize that CapEx, but have a structured modular approach that you can essentially have a page out of that just-in-time playbook to deliver the services you need most cost effectively, but when the demand actually presents itself, as opposed to let's go build, a megawatt data center and hope that the customers come. That's just not a good investment strategy for us.
That's great. I mean, you even answered one of the audience questions. If those things are, if the rising capacity is just a prediction, or is it something that you see? So thank you for that. So at this point, I would like to poll the audience with a question, and that will be, What do you think will be the biggest game changer or the most disruptive technology over the next 10 years? Would it be software-defined data centers, rack-scale design, edge computing, connectivity, cloud, or will it be in open source architectures? We'll take a minute. We have 9 responses so far. We'll take a couple more seconds. Software-defined data centers and edge computing are pretty neck and neck so far. All right, so I'm going to close the poll now, and let's take a look at the results. All right, edge computing is the winner. So the results are in, and I would like to end our webinar by asking each of our experts to share with us their prediction on what they think will be the biggest game changer or the most disruptive technology over the next 10 years. We'll start with Ken.
You know, I think it's a combination of what Jim's response was in the last question, as well as a part of Jeff's initial presentation. You know, I think percent utilization of the infrastructure, you know, that's available. How much do you use? You know, how much are you building out day one? You know, that has a direct relationship with the CapEx, you know, for the organization. They don't want to build out the entire space, but the caveat is you need capacity on demand. You know, and it's incumbent upon us as manufacturers to build the product that our customers, the market is demanding, and not vice versa. We should not dictate what the market uses. You know, and I think that's going to be the most disruptive thing for us as manufacturers and suppliers, is to put out there exactly what the customer uses. So I think, you know, as from a big picture point of view, I think all of these components that we talked about today are going to be disruptive for manufacturers and suppliers. You know, it's going to be up to us to provide exactly what the customer needs, and that's evolving, and that will be changing.
Jim?
Predictions. I think in some respects, I think the current state of design particularly in the colo arena is, you know, in my view, probably about, you know, 10 years behind the curve. So if I had to think about, you know, big data center disruption, I'd say it's probably the next wave of data center designs when the colos finally get caught up with and implementing a lot of the concepts we're talking about here today. I really could see data centers getting physically much smaller, consuming far less real estate, wasting less energy and water, and at the same time getting much closer to customers, supporting much higher densities at a lower cost for customers, but at the same time delivering actually better profits for the colo operators. So I think it's taking a while. I think that one of the earlier slides that Jeff was showing was looking at kind of, you know, where the trends are happening. So I think it's an increase in densities. It's inevitable. It's happening at different paces. At what point does that become mainstream enough to attract the attention of the colo providers and the cloud providers, you know, indirectly, to really start saying, okay, you know, things are now sufficiently at scale where let's look at this in a different way, because, you know, what Ken was even touching on earlier, you know, continuing to blow air around is just inherently far more inefficient. So I could see a lot of changes happening in the data center design space and kind of creating a much more modern type of model that costs less to build and costs less to the customer, but improves the profit margins for the colo operators.
All right. Jeff, any final word? You have 10 seconds. Sorry.
Okay, no, just I reiterate software defined. I think the iterative steps are going to be more software driven data centers. Jim talked about capturing more data, but I think there's still more work to be done to get the DSIM more affordable, easier to implement, and then tying in not just capturing that data, but what do you do with it? So it's basically becoming more autonomous and more predictive in your controls, and optimizing your facilities to your workloads.
Awesome. At this time, I'd like to thank Jim, Jeff, and Ken for taking time to share their valuable insights. I'd also like to thank our audience for joining us, and hope to see you all soon. Have a great day.